Change Economics Part 2, the lecture notes, starting with economics of planet insurance. So here's the question of how we would frame the climate change question as an economist. So first we got to think about it as a choice under risk. And to me, most environmental policy, most policy in general, is a lottery. You know, we're making investments to change the odds that good things happen and bad things don't. And that's really what we're up to. We don't have 100% certainty that it's going to be a good outcome or it's going to be a bad outcome. We have different odds that we're shifting and that we are trying to invest real resources, real money, real time, real effort to try to make it more likely that good things happen. So I think of these problems in terms of probability and severity of the outcome. So what's the probability of a bad event happening and what's the damage associated with it? So the P is the probability and D is the severity or the damage. And so we try to frame these things as a portfolio of risk management tools in order to be able to reduce the risk cost effectively so that we at least are more likely that good things happen than bad things. I mean, to me, it's that simple, even though the way to do it is not simple. Right? So we're thinking about this portfolio of risk management tools, and when we come to climate change, we're talking about mitigation, which is reducing carbon emissions one way or another, either by less fossil fuels or by carbon capture, which is going to reduce the probability of a bad event. Or we're going to adapt, which means investing in seawalls or in different crops or in different machinery or different technologies, that if what that implies is that if we do realize a bad state of the world, the damages are going to be smaller. And we think about insurance, which is putting money away for a rainy day so that if a bad event is realized, we can transfer that money so that the net effect is not as bad as it could be. It's just like any kind of insurance. If you have a car accident, your insurance helps pay for some fraction of the damages as opposed to you, just like health insurance. So the goal is to protect the planet and us humans cost effectively and try to figure out the best way to set up a mitigation, adaptation, insurance scheme so that we can lower the risk as much as possible at the least amount of cost. And so we're balancing these expected costs and benefits of doing things to address climate change. All right, mitigation. So again, reducing carbon emissions, and we're trying to lower the probability of a bad event being realized. And a bad event in this case is some kind of climatic change that we can't control that leads to damages like more hurricanes or more tornadoes or more pandemics. So part of this is thinking about what we call the fat tail on damages. So a typical distribution would be the light gray curve in which we have a distribution around damages. The fat tails is this notion that the chances of these really bad events happening are more than we thought. They're not just asymptotically approaching zero as it would look like on the bell curve, but instead they're asymptotically approaching some positive number. So indeed, if the climate change damages are approaching infinity, infinity times a positive probability is still infinity. So the idea here is to think about climate change and which distribution is more accurate in terms of how we should think about these expected costs and benefits. And this matters when you think about those damages that we talked about before, this reduction in world GDP. So if we're starting at the year 2000 up on the left side, and we go down the axis, the x-axis there in terms, or the y-axis in terms of percent reduction in world GDP, we can see that if you believe in sort of this fat tails argument, that's going to be that big orange line in terms of the drop in GDP if climate change is realized and if it's an extremely bad event, versus the smaller drop in the red line that if it's a climate change event happens and we can adapt and we can ensure that yes, there's going to be damages, but it's not as bad as if we could not control it. So when we think about previous studies, the drop in GDP was negative and positive. They were pretty all over the board, and you could actually have climate change helping in some different models because agriculture would be more productive, you would have longer growing periods, you would have more time that you could spend in a nicer climate or a warmer climate. Well, that was in the early 90s and throughout 2000. With the Stern report, they put all of the estimates, all of the damage cost estimates into negative GDP, which implied that the risks are most likely going to lead to some sort of damage. The question is, how much? Now, with adaptation, again, the question is, can people adapt to rapid changes in the regional and local climates? Can we reduce the size of these damages by making changes in how we run our economy? Can we make our economy climate proof? I mean, right now in the U.S., most of our economy, 3% of our economy depends on climate because we have such a service-based industry and we have so much technology involved. Now, if you go to Africa, Central America, parts of South America, they're way more based on climate, where agriculture is a bigger part of their country's GDP. So how well they can adapt is going to depend on the information they have and the research and development and the new technologies they can use. Can they find crops that are more heat tolerant? Can they find crops that are more drought tolerant? How do we figure out how to grow things in a changing environment that we've never confronted? I mean, just think of the COVID now as this risk in this global pandemic. People are reacting as best we can in real time because we've never really seen anything like this in our lifetimes. You know, a global pandemic of this nature hasn't come around since nearly 102 years ago, even though there's been other pandemics, but something of this nature. And again, what it implies in terms of adaptation is that if we're able to adapt, that means that that bottom light blue line might not be as bad as we thought because we adapted to it. And so instead, we're at, follow that crooked orange arrow there, we're actually somewhere closer to the not having any damages. And same with the red line. If we adapt, now we're at the light blue line, which is practically no drop in GDP. Again, this is hypothetical, and the question is whether we can find these technologies to be able to do this. The cost of doing something, well, when I worked in the White House, we got lobbied from a lot of different business groups that said, look, this is an economic disarmament. I mean, we're essentially giving up our economy for something that might happen 50, 100 years ago, and from now, not years ago, that might happen 100 years from now, 50 years in the future, and we just can't afford to do that. There are people who need jobs now. Versus the environmental groups, which said changing our economy essentially is zero cost. It's like no pain, big gain. The other one is all pain, no gain. And really, it amounts to something in between, which is there's going to be a cost, there's going to be a pain, and the question is, can we anticipate how big the gain will be if we're more ready to handle a changing climate in our economy when it actually happens? I mean, this is all in the future, and we're all prepping for it, and we're all trying to think about what we can do. So if you're a clever entrepreneur, you should be thinking about how your business is going to adjust to a changing climate. And if you can get ahead of the curve, you can make a lot of money. If you're good at solar power, if you're good at wind power, if you're good at the renewable energy sources, if you can build a better battery, that is really the key, right? Elon Musk is investing tons of resources to build a better battery because, in his mind, that's where everybody's headed in terms of how to handle this energy sources. Because if we have better batteries, we're able to capture the solar power, we're able to capture the wind power and store it when otherwise it is more fleeting and more, you can only get the solar power when the sun's out. So how do you store it at night when you need it? Costs, well, the costs are really going to depend on whether we're going to allow global emissions trading. So what is global emissions trading? Global emissions trading is the idea of cap and trade. So you probably heard the term cap and trade, which means setting a level of pollution, or in this case, a level of carbon emissions, and then allowing people to buy and sell those carbon emissions just like we would buy and sell hunting permits or any kind of permits that allowed us to access to whatever it is we wanted. So, we're just essentially setting a limit on pollution and making pollutions have value by making the atmosphere a scarce resource. And with this economic instrument, cap and trade, we're essentially we're creating a market is what we're doing. We're creating a new market. And by creating a new market, there's efficiency gains because people who are high cost producers can buy permits from low cost producers. We create value through trade, but now we're creating value by selling pollution, by selling carbon. And the drop in costs from 2% of world GDP to 0.5% of world GDP is a huge amount of resources. So again, if you're an entrepreneur, here's a chance to get out and do something and make some money by figuring out how you can buy and sell carbon, right? There is a carbon market in Europe. There was a futures market in the US that has dried up, but this is where we're headed. And again, if you're on top of it, this is another source of big money in the sense of if you can provide this market, if you can fill this missing market, you can contribute both to controlling climate change and to creating jobs, and it's win-win on both sides. Right? So this world GDP graph here, in terms of the cost. So if you think of the red line and the blue line as marginal cost curves, then what we have is a drop with cap and trade from the orange to the blue line in terms of a much cheaper way to reduce carbon emissions around the planet. Now, the trick, of course, is if you're talking about global emissions trading, you're talking about trading with Russia and China and all around the globe. And so this climate policy here is going to depend on this flexible incentive system, the cap and trade, or a carbon tax. And in day 2, we'll talk about carbon pricing in a lot of detail. So this is just a quick fly through. We'll talk about participation, or we also, so slow down. 3 key factors: flexible incentive system, that the emerging and developing countries participate in this because that's where a lot of the low cost carbon reductions can come from. And we have to talk about the adoption of low carbon energy technologies. And that again would be finding different ways to use renewable energy, batteries again, thinking about ways to be more efficient with fossil fuel use, figuring out carbon offsets, figuring out carbon storage. Wyoming is thinking about a lot of that in sense of how do we use coal for something other than burning for energy? Can we use it to capture carbon? Again, if you're a clever engineer, the opportunities here to make a heck of a career over the next 40 years are nearly endless. And this is where we're going to stop again, and we will pick up in part 3 in terms of looking at the policy tools.